Well, hello. Today we're going to talk about electricity and specifically series circuits. With a series circuit, or any electrical circuit, a set of electrical components connected such that they provide one or more complete paths for the movement of charges. And as you can see here, then, we have a battery, we have this circuit, and then you have the filament here. The electricity would be going through the filament and then out the other way. This is actually an open circuit because it wouldn't be able to go. In this case, I want to show you that our equation V equals IR is still working. V the V is the 1.4 volts, I is the 0.5 amps, and we could solve for the R. Closed circuit, the path produced when a load such as a string of light bulbs is connected across a source of voltage. Required items. For there to be a closed circuit, there has to be a voltage source, it has to be a battery or an outlet, and there has to be an electrical device. So examples of this voltage source could be like a hair dryer. The battery or an outlet could be just simply a battery, or you have it plugged into an outlet. Check that. Voltage source could be the battery or the outlet. The electrical device could be like a hair dryer. Open circuit is without a complete path and a source of voltage. There's no charge, therefore no current. If the electricity can't flow, then there's not going to be any current flowing through it. This right here would be an example of an open circuit. We have the current would be flowing to the batteries, or we'd want it to be a wire going to the batteries, and then to here. This would be like our circuit breaker, our circuit boards we were working on the other day, and we have these resistors. Well, this is an open circuit right now because there's not going to be anything that's connecting any of the resistors back to where we had started. And as I'm pointing out here, I decided to go ahead and draw on the wires. This is an open circuit. We have something missing here and here. There's no complete path there. And that's why it's an open circuit. There's not going to be any charge flow, therefore no current. Now we've closed the circuit, and it's no longer an open circuit, but indeed a closed circuit. What are circuits? A switch interrupts the flow of charges in a circuit. A switch opens and closes a circuit. Schematic diagrams represent circuits. In a schematic diagram, all electrical devices can be described by using standard symbols. Schematic diagrams are used quite a bit by electricians. And we're going to actually do some work with it here in the next couple days, working on these schematic diagrams. Some examples here of a schematic diagram. What you have down here then is a resistor. That's one simple way. Then we have the battery. This is how we'd show a DC voltage source for a battery. And this is an AC, although we won't really do much at all with AC, so I wouldn't worry about it too much. Here's a light bulb. Another way they can show a light bulb is by simply drawing it like this, and then as you can see, there's a couple ways you can show a light bulb, and that's kind of the artistic of a schematic. Series circuits. Alright, this is what we're getting into today. First of all, they form a single path for current to flow. As you can see here, there's only one path. There's no way for them to go in separate directions. There's no place for it to split. It's going to go through each of the resistors. The current in each device is the same, so each one of these is going to get the same amount of current. If one of them is going to get 5 amps, then all three of them are going to get 5 amps. The voltage across each device can be different. Resistor 1 could be getting 2 volts. Alright. This could be getting 3, and this could be getting 5. Let's see, what else do we want to talk about here? If one element along the path in a series circuit is removed, the circuit will not work. Okay, what I want to point out to you here then is this is a switch, and here's a switch on a schematic. Here's a light bulb, here's a light bulb, light bulb, light bulb, light bulb, light bulb. Now the reason I drew the circles around them is to make them look like light bulbs instead of resistors. This is actually a picture I found on the internet, and I tried to match it up with this so that it'd be the same, but battery, battery, switch, switch, 3 light bulbs, 3 light bulbs, and all we do to a resistor is put a circle around it to make it a light bulb. If any one of these light bulbs is unscrewed, this is going to, if it's removed, the circuit's not going to work in a series circuit. Alright, let's talk about some math here then. Or at least a schematic here of this. Let's check what I was saying there. In this case, we've got the 2 batteries over here on the left hand side. We've got the switch, and we've got several resistors here, as I've labeled. And we're drawing a simple circuit going through the 10 ohm resistor. So we've got the switch, the 2 batteries, and the 10 ohm resistor. So over here now, I'm drawing the battery. We've got the first resistor. We've got a switch. We're going in here. Now, here's the switch, here's the resistor, this is the battery. On the test, what a lot of students typically start doing is they draw this for me when I ask for the schematic. This is not a schematic. This over here on the right was the schematic. So now we're going to change it. The battery is going to stay the same. The switch is going to stay the same. All we're doing now is we're going to put in another 10. We're going to put another 51. And then we're going to go back to the end here. So we're going to come off of the battery. And we're going to put a resistor in. That's our 10 ohm. This is the next 10 ohm. And then this is the 51 ohm. So this, again, this one over here to the right is the schematic that we'd want to draw. Okay. Now what we're talking about here is we're going to show the math. Alright. What we're going to do here then is we're going to figure out how to do some of the math then for this circuit. So right here we're going to go through our steps. Alright, we've got these 4 steps for being able to figure out what is the voltage and the current and the resistance through these. And So this is what we're going to do here. The first thing is make sure we know in a series circuit that the current is the same in each device. The voltage can be different. Our first rule is to plug in the givens. In a series circuit, then, the givens are that the one resistor is a 10 ohm and the other one's a 68 ohm. So let's go ahead and fill in then in the chart the 10 ohm and 68 ohm. Now, while you guys are making the chart here, I want to, oh, and it's also 3 volts. I want to make sure I point out to you that in this chart we have V, I, and R, Ohm's law. V total, I total, and resistance total. For this, alright, our second step is to use concepts. Alright, use concepts. The one thing I left out here is we need to find RT. Alright, we need to find RT. In a series circuit, the way we go about finding the total resistance is that we need to add R1 and R2. We just simply add them. 10 plus 68 gives us 78 ohms. And then we need to find IT. Well, how do we go about finding IT? We say V equals IR. So we put in what we know. 3 goes in for V, 78 goes in for the R, solve for the I. And we get 0.04 amps. And that means there we're going to get 0.04 amps. Now, in a series circuit, we learned that all of this is getting the same amount of current. There's only one path, so there's no way for it to split. So I1 and I2 have to be getting that same amount of current. That's our concept. In a series circuit, they get the same current. Step 3, use V equals IR. Well, that's what we're going to do here. 0.04 times 10, which gives us 0.4 volts. Here we're going to use 0.04 times 68 because I times R equals V. And that gives us 2.7 volts. Key concepts for series circuits. Every one of them gets the same current. Key concept for series circuits. Every one of them gets the same current. Key concept for series circuits. Every one of them gets the same current. They can have different voltages. Right? Again, there's a single path. Because of that single path, they're going to each get the same amount of current. Well, hey, we're going to call it quits here for the day. I'll catch you guys on the flip side.